Hello, good day everyone. We are now on the second part of our course, Elementary Probability and Statistics. So we are now on the probability part after having discussed all the topics for the elementary statistics. So let's have the normal distribution as the first lesson for this particular chapter. So what is a normal distribution? To be able to understand this particular topic, we need to identify the different properties of the normal distribution. The normal distribution is a continuous probability distribution that is symmetrical on both sides of the mean. So when we say symmetrical on both sides of the mean, so it means that the right side of the center is a mirror image of the left side. So the broken line that you can see on your screens is the mean. So that divides the overall picture into two equal parts. The area under the normal distribution curve represents probability. That is why this can be used in probability problems. That is why this is part of the introduction to the probability topic. And aside from probability, percentage can also be used as the term that we will be finding out in solving for the areas under this particular curve. And we have to take note that the total area under the curve sums to 1. Just like in the probability, when you are computing for the probability, the highest value is 1, which represents 100%. Or that means that there is 100% of chance that that particular thing will really happen. So that is just similar to this kind of percentage. Most of the continuous data values in a normal distribution tend to cluster around the mean. And the further the value is from the mean, the less likely it is to happen. So thus explains the form of the shape of the curve, which is just like a bell. So high frequency of observations gather around the mean. That is the center of the distribution. And less frequencies are observed at the extreme values, so at both ends of the distribution or data set. The tails are asymptotic. So what do you mean by asymptotic? So it means that the tails approach but never quite meet the horizon or the x-axis. So that is one of the properties of the normal distribution or the normal curve that we are explaining right now. For a perfectly normal distribution, the mean, the median, and the mode, the three measures of central tendency, will be the same value. So in other cases, there are values that are almost the same, and if we are going to form that into a graph, you can still form a normal curve. But if that is a perfectly normal distribution, then the mean, the median, and the mode are of equal values, visually represented by the peak of the curve, as you can see. The normal distribution is often called the bell curve because the graph of its probability density looks like a bell, as what I have mentioned a while ago. But it is also known as the Gaussian distribution after the German mathematician Carl Gauss, who first described it. So in other textbooks, this is also known as the Gaussian distribution. That's a trivia. So the next part is we have to know why is it important to deal with this kind of distribution. Why is the normal distribution important? So it's important because this is mostly used not only in our lesson when we talk about academic probability and statistics, but in terms of doing research in nature and psychology, this is very much used. The normal distribution is the most important probability distribution. We have to know this. This is the most important probability distribution in statistics because many continuous data in nature and psychology displays this bell-shaped curve when compiled and graphed. So based on history, on countless research studies made, most of the data really follow this particular pattern, a curve. For example, if we randomly sampled 100 individuals, that would be expected to see that their responses when graphed will form a normal distribution curve or this kind of curve. So examples of that, maybe if you are going to research about the IQ of the students or their scores in a particular test or even the blood pressure of the patients. And when we are talking about large size or the population is large, when we are not talking about simple getting 10 or 5 respondents out of the group, then we can really create a normal distribution. That is in the usual picture or scenario. So that is why it is very important to study this kind of distribution. Another one, parametric significance tests require a normal distribution of the sample's data points. So what are these parametric significance tests? The most powerful statistical tests are known as the parametric significance tests, and that is what we are studying in the field of statistics. And when we are reading results of studies, most of these are actually out of the parametric significance test. Just like the t-test, what else? The Pearson R coefficient, when we are trying to gauge if there is a relationship between variables. So these are some of the important examples of parametric statistical tests that we are using. It's because we are requiring our data to be of normal distribution. So mas malaki ang power ng result ng data mo if you are using parametric significance test. And this only happens, you can only use this test if your data follows a normal distribution or a normal curve shape. So if the data does not resemble a bell curve, researchers may have to use a less powerful type of statistical test. There are cases when we cannot really form a bell-shaped curve, so there is no choice for a particular researchers but to just accept the fact and what will be the impact of that. The result of the study will be less powerful and less convincing and less useful in terms of usage in general. So that's the difference between the parametric and the non-parametric significance test. So that is the explanation of that. The most powerful tests used by psychologists require data to be normally distributed. Another one, converting the raw scores of a normal distribution to z-scores or standard scores is only possible with normal distribution. So this particular concept that I am talking about right now, the z-scores, converting raw scores to normal distribution z-scores, is actually the next topic. So we will be dealing with this thoroughly in our next lesson. This procedure allows researchers to determine the proportion of the values that fall within a specified number of standard deviations from the mean. That will lead us to empirical rule. Since this has been practiced before and they have already seen the pattern that if your data follows a normal distribution or a bell shape, then we can have this kind of graph, and then afterwards they were able to set a particular standard normal distribution. That is why the empirical rule has been created. That will be presented in the next slide. So here we have the probability and the normal curve for the empirical rule. So what is the empirical rule? The empirical rule in statistics allows researchers to determine the proportion of values that fall within the certain distances from the mean. So as you can see in the picture right now, we have here the normal curve, but we have calculations of the percentage or the probabilities under that particular area of the curve. So the empirical rule is often referred to as the 3 sigma rule or the 68, the 95, and 99.7 rule. So again, it is the 68, 95, 99.7 rule. So that is the name of the empirical rule for you to be able to recall all the time those significant numbers. If the data values in the normal distribution are converted to z-scores, because we have different data from the different researches and different variables that we are studying, so we can have different normal curves. But if we are going to standardize that to convert those items into z-scores, then we can form the standard normal distribution. And after that, we can now apply the empirical rule. So again, the empirical rule describes the percentage of data that falls within specific numbers of standard deviations from the mean. So this particular letter that is at the very center, this is read as mu, is actually the mean. And if you are going one step to the left and to the right, that is already one standard deviation away from the mean. That is with the color pink. If you are going to proceed to another level, you are going further, another standard deviation away from the mean. And so when you are proceeding to another region that is colored green, you have there the mu minus 3 and small letter sigma. The sigma there represents the standard deviation. So generally, it represents the distance of a particular value from the mean. And the distance is known as the standard deviation. So if I go one standard deviation away from the mean, I will have this particular value. So if I will have one standard deviation away from the mean from the right side as well as of the left side, that constitutes 68.27% to be exact. Or generally, that's 68% in the empirical rule. If you will go further, if you will have two distances or two standard deviations away from the mean, so that will give you a total of 95.45%. Two standard deviations away from the mean, that is on both sides of the mean. And so on and so forth. So that is the general rule for the empirical rule. It is often referred to as 68, 95, 99.7 rule. The empirical rule allows researchers to calculate the probability of randomly obtained or obtaining a score of a normal distribution. So that is the example given a while ago. The 68% is the percentage or the probability from the mean going one standard deviation away from it on your left as well as on your right side. So the color pink constitutes 68% out of the overall area under the normal curve. So 68% of the data falls within the first standard deviation from the mean. This means there is a 68% probability of randomly selecting a score between -1 and +1 standard deviations from the mean. So if that is the mean, 0, it means that we are not moving away from it. That is the center. If we are moving one step to the right, it means that we are going one standard deviation away from the mean. In the very same way, if we are going one step away, going to the left, we are having a -1 standard deviation from the mean. So getting the distance from that particular point, -1 as well as +1, the area between that is 68%. That is the meaning of the first part of the empirical rule. The second part, if you are going further away from the mean, so from the mean that is 0, the standard deviation is still 0 because you are not moving. You're moving 2 steps away or 2 standard deviations away from the mean. So you have -2 on your left as well as +2 on the right. And from that boundary, the area involved at the center is equivalent to 95%. So it means to say 95% of the values fall within 2 standard deviations from the mean. This means that there is a 95% probability of randomly selecting a score between -2 and +2 standard deviations from the mean. That is the second part of the empirical rule. The third part, this 99.7% of the data will fall within 3 standard deviations from the mean. So if you will go further, you will have -3 on your left and +3 on your right. So this constitute for the overall area under this particular distances of your curve, this constitutes to almost 100%. So there is still a margin of error. And that is also the explanation why we cannot really reach exactly 100%. It's because of one property of the normal curve that is asymptotic. Yeah, that's the correct word, asymptotic. Because of the asymptote that is formed by the curve. So because it is asymptotic, therefore we cannot really produce 100% because there is no closure to your graph, to the values. So 99.7%, that's the highest value or area that we can get out of the areas under the normal curve. So 99% of the data will fall within 3 standard deviations from the mean. This means that there is 99.7% probability of randomly selecting a score between -3 and +3, that's the standard deviation, from the mean. So to be able to be understood clearly, let's have this picture. This is the summary of what we have just discussed. So if we have 68% within one standard deviation, if we are going to divide that, since the mean is at the center, it gives us 34% on your left as well as 34% on your right when you are talking about the first part of the empirical rule. So 34 plus 34 will give us 68%. If we are going to move further on the second standard deviation away from the mean, we can have 95%. If you are going to get exactly what is the percentage or probability or the area of the second part after the 34%, you'll have 13.5%. That's on the right side as well as on the left side. So if you're going to add 13.5, 34, 34, and 13.5, that actually comprised the 95% area or the second part of the empirical rule, and so on and so forth. So we have 2.4 here and 2.4 on the other side to complete the 99.7% of the data that is part of also of the empirical rule, considering that you have already moved further from the mean. So let's have an example. So this is the example that I'm talking about to clearly understand the application of such concept about the normal distribution and the empirical rule. So I will read. Suppose you know that the prices paid for a bicycle are normally distributed with a mean of 17,000 pesos and a standard deviation of 500 pesos out of the data collected from 200 buyers. So we are going to see the picture of that particular scenario in a normal distribution. Again, we are assuming that after getting all the data from 200 buyers, we have come up with a normal distribution. So this is now the graph of your data. At the very center is 17,000, that represents the mean. So the centermost, again, one of the properties of the normal curve or normal distribution is the mean is at the center. So probably this is also the median and the mode if you are going to compute for the other measures of central tendency. So since the standard deviation is 500 pesos, so there will be deficit of 500 pesos on the left side, and you're going to add another 500 pesos to the right side. That's why we have 16,500 as our next entry from 17,000 pesos on our left side, and we have 17,500 as our next value on the right. So the interval is 500 because that is the standard deviation. So what are the interpretations that we can get out of this based on the empirical rule? So we have learned that between these two values from 16,500 to 17,500, the area covered is 68%. So what is now the interpretation of this using the empirical rule? So we can further divide this. 34% is the area from 16,500 to 17,000 pesos, and another 34% from 17,000 pesos to 17,500. So I'm talking about the percentage of buyers because we are dealing with the buyers of bike. So ang ibig sabihin nito, 68% ng mga buyers or mamimili ang kumuha ng mga presyo between 16,500 and 17,500. Or if you're going to put that into details, 34% of which of the 200 buyers paid around between 16,500 to 17,500. The same percentage also paid 17,000 pesos to 17,500. So that is the 68% for the first part of the empirical rule. For the second part, that is already 2 standard deviations away from the mean. That is already 95%. So it means that this side on the leftmost from 16,000 to 16,500 is 13% of the overall curve, while on the other side from 17,500 to 18,000 pesos, you have also 13.5%. So don't forget those numbers, because that is actually constant when you are interpreting normal curves. So what are the other values left? We have 2.35 and 2.35 to give 99.7%. And we also have 0.15, 0.15 on the other side. So these are the interpretations. We can actually get a lot of interpretations from this example. These are some of the few. 68% of the buyers. So what is 68% of 200, since there are 200 buyers? So we can say that 136 buyers actually paid between 16,500 to 17,500 pesos. 95% of the buyers, or 190 buyers, if you are going to count them, actually paid between 16,000 pesos to 18,000 pesos. You can actually observe that in our graph. So that's 16,000 pesos to 18,000 pesos, and you are going to, if you are going to add those numbers, 13.5%, 34%, 34%, and 13.5%, that will give you 95% of the buyers, or 190 out of 200. So that is how to interpret. These are just few of the things that we are going to interpret. So how about this one? How are you going to complete this sentence? How many percent of the buyers, or you give the number, paid between 16,000 pesos to 17,000 pesos? So if you are going to look at 16,000 and 17,000, 16,000 is 2 standard deviation away from the mean, but the movement is only on the left side, on one side. So you have actually you have only consumed 34% and 13.5%. So that is only the area or the percentage covered for those amounts, 16,000 and 17,000 pesos. Therefore, we have 47.5%, 13.5% plus 34.0%, that's 47.5%. If you are going to get the number of buyers or persons out of this, what is 47.5% of 200? So there are 95 buyers who paid 16,000 to 17,000 pesos for a bicycle. I hope you got it. Another one, how many percent of the buyers, how many of them paid below 16,000 pesos? So I will give you time to think about the answer. You can pause the video and you can continue. I will now give you the answer. So 16,000 pesos is found at the left side, of course, of our mean. Since we are talking about the amount below it, so we will look at the leftmost part. We have 2.35% and 0.15%. So if you're going to add the two numbers, that will be the percentage, 2.5%. 2.5% of 200 is 5. So it means that only 5 bicycle buyers paid 16,000 pesos below. Another one, blank percent of the buyers paid 17,500 and above, or above 17,500. Okay, so if you are going to look at 17,500 and the areas to its right, you have 13.5, 2.35, and 0.15. That gives us 16%, and 16% of 200 is 32. So 32 buyers paid above 17,500 for a bicycle. So this is just a good example to be able to clearly understand and appreciate the work of empirical rule when we talk about the normal distribution. So to be clear again, we can only use this interpretation if we are dealing with a normal distribution or if we are going to construct a normal curve out of our data. So the question is, how can I check if my data follows a normal distribution? How will I know if all this data that I have gathered can be formed into a normal curve? So here are the things that you can use. You can use the SPSS or the statistical package for social sciences. That is a software that you can actually buy online. You have to use the licensed one to check if your data is normally distributed. You can also get an idea about the distribution if you have the values for the mean, the median, and the mode. If the mean, the median, and the mode are exactly the same or they are very similar, then you have the assurance that it is of normal distribution. The third one is you can actually check the visual shape of your data if you are going to graph it yourself. So that is the limitation of this study. This can only be applied if you are talking about the normal distribution. So that ends our lesson about normal distribution. After this, we will be dealing with the other examples of normal distribution applying the standard normal distribution and the z-scores. So that would be all. The reference is there. If you want to read more about this lesson, you can also read this one, or you can look for other references about normal